Assalamualaikum and a very good morning to all my students. So for today's lecture, we will cover chapter 2.2, which is chain growth polymerization. So we have done about step growth polymerization. So look at the lesson outcomes. Upon the completion of this chapter, students should be able to first describe the characteristic of chain growth polymerization, distinguish between step growth and the chain growth polymerization, write the initiators for free radical polymerization, write the chemical reaction mechanism for free radical polymerization, differentiate between the termination step involved in free radical polymerization, write and explain the kinetics of free radical polymerization, describe the inhibition and retardation process, and last one, explain the auto acceleration. Okay, for chain growth polymerization, they have 5 types of polymerization, which are free radical, cationic, anionic, leaving, and coordination polymerization. So all these type of polymerization have their own initiators and also have their own kinetic. We will look at each of that. Okay, for step growth polymerization, we have covered about step growth, which contain polycondensation and polyaddition. So there are some differences between step and chain growth. Okay, as we know, in step growth, high molecular weight is only achieved at very high conversion. So meaning that the molecular weight increase with conversion. So high molecular weight is only achieved at the end of the reaction. While for chain growth polymerization is a process in which the high molecular weight polymer is formed early in the polymerization process, and the polymer yield, which is the the percentage conversion of the monomer into the polymer, will gradually increases with time. So molecular weight is generally unaffected by the conversion. For step growth, any two molecular species can react, but for chain growth, monomer can react only with reactive species. So there must be the presence of the initiator, which react as the reactive species. Monomer concentration decrease rapidly in early stage of reaction, while for chain growth, monomer concentration decrease continuously throughout the reaction. So the last one, the reaction mixture contains a range of different size species. For chain growth, reaction mixture contains only high polymer, monomer, and reactive species. Okay, this is some general diagram for step growth and the chain growth. So this is the short chain. Okay, step growth polymerization. The first monomer here, then react with another monomer here, then it produces a short chain. So it takes several time for the high monomer, which is high polymer, to be a large molecule. So if we look at this chain growth polymerization, even at this stage, they managed to get high polymer chain. Okay. The comparison between step growth and the chain growth polymerization according to the average chain length. So the average chain length of a polymer as a function of the fraction of reacted monomer, which is P, in chain polymerization. Okay, this is the chain polymerization. So high molecular weight polymer is obtained at the early state of the reaction. So this one is a step growth. The green one is a step growth polymerization, which is high molecular weight polymer is achieved at the late state of the reaction. So P must be very close to 1 for the chain to be long. So P cannot be more than 1. It must be equal or same with 1. Same to 1. Okay. Okay, what is chain growth polymerization? So chain growth, also known as addition polymerization. This polymerization technique where the unsaturated monomer, which is monomer that contain double bond, add onto a growing polymer chain one at a time. So in chain growth polymerization, it requires the presence of the initiator to start the reaction. The initiator will continually generate growth centers, which is reacting as initiating species, which add on monomer molecules rapidly. So when it undergoes initiation, so it will then proceed with propagation and termination. The polymer formed from chain growth or addition polymerization contains all the atoms of the starting monomer. So the number of atoms from the beginning to the end is remain the same. The molecular weight of an addition polymer is a multiple of the molecular weight of the monomer units. This is example of chain growth polymerization. You can see the presence of double bond for the monomer. So the number of atoms here remain the same from beginning until the end of the polymer produced. Okay, it takes place in 3 distinct steps. First, initiation, and then propagation and termination. So the principal mechanism of polymer formation is by addition of monomer molecule to a growing chain. Means that if a polymer A react with initiator, so it will produce AI with radical formation. So AI with radical formation, it will then react with the monomer itself again and produce monomer with the presence of the radical. And then the propagation step will propagate more until at the end of the process it will be terminated. Okay, later I will show you the diagram. Okay, the consideration or the properties of the monomer must contain double bond. So the general formula is carbon, carbon, and double bond. Susceptible to attack by free radical or ionic initiator to form the active center. So monomer will react with initiator to form the monomer with initiator. And this one is the symbol for active site. So we call it as the initiating species. Okay, it acts as the growth or active center. So based upon the growth centers, chain growth polymerization can be classified as free radical, ionic, and coordination. Okay, polymerizability of monomers. So the monomer that can polymerize by using chain growth is alkene, carbonyl, heterocycle, all capable of reacting in this manner. Means that all these monomer must react with the active site. So the activated species can be radical, anion, cation, or more complex species. Carbonyl and heterocycles are not polymerized by radicals. Alkenes may react via any of these intermediates depending upon the nature of the X group, which is a dependent group. So this is the formation of active intermediate. Okay, this is carbon with hydrogen bond here and the methyl group. This is we call it active site. So the 7 electron, which is electron deficit have a charge equal to 0, usually radical ion are possible. This is the carbocation ion, which is have positive active center, which is the Lewis. Okay, this is the carbon ion. Okay, which are negative ion, negative charge, which is the Lewis base. So we will look at this subchapter in the next slide. Some substituent effect versus the initiator. Okay, this is the mechanism of chain growth polymerization. So all the reaction, exception for leaving polymerization in chain growth will react by the following mechanism. First, the generation of active initiator reaction with monomer to form growing chain. So all the step in chain growth polymerization, it must be start with the initiation first. Okay, so generally we call it as the okay, generally we start with the initiation by dissociation of the initiator itself, and then proceed with initiation by association. So initiation actually can be divided into two, which is by dissociation and association of the initiator. Okay, the next step is propagation. So chain extension by incremental monomer addition, which is chain will be propagate into more complex polymer. So the next step is the termination, which is the conversion of active growing chains to inert polymer, and the polymerization cannot proceed further because the chain has been terminated. And the chain transfer agent is the transfer of active growing site by terminating one chain and reinitiating a new chain. Okay, we start with free radical polymerization. So hope you can catch up because this involves a chemical reaction process, and you must be prepared to study more about the complex structure. Okay, free radical polymerization is the most widely used process for the production of most important vinyl polymer and copolymer. For example, polymer that contains of double bond and copolymer, which are PE, PVC, and so on. It is much less sensitive to the effect of impurities than ionic polymerization. So it's much faster than step growth polymerization. So the active center are the free radicals. Okay, for the beginning, polymerization steps start with the initiation. So initiator molecule generate free radical, which is primary radical in the reaction mass, and then the step proceed with the propagation. Okay, the notes here is same with the previous notes, and the last one is the termination, which is termination of the active chain to give the final product. Okay, for initiator, so which act as the radical generators. For free radical, we have four types of initiator. Okay, first peroxide, azo compound, photoinitiator, and redox system. So for peroxide and azo compound, there are thermal decomposition or UV decomposition. Okay, types of initiator for peroxide and hydroperoxide. Example of peroxide and hydroperoxide are BPO. Okay. BPO stand for benzoyl peroxide. So the reaction temperature at 80 to 90 degrees C by thermal or UV decomposition. Okay, so the reaction condition need this range of temperature. Okay, by thermal, by heating it, or under UV. Stable enough that it's trying to react with more reactive monomer molecule before eliminating carbon dioxide. thus reducing initiator wastage.